Page 6 is modeled just like after a lab that we did where you were given an unknown sample and trying to figure out what that metal was. It's based on two physical properties, density and specific heat. Density is simply equal to mass divided by volume. So I have to figure out how much mass of sample I have. 78 grams. And what is its volume? Well, when we put it into a graduated cylinder, it rose from 31.2 to 62.4. So 62.4 minus 31.2, it's a change of 31.2. 78 divided by 31.2 equals 2.5 grams per milliliter. If I was to go down and try to figure out which density that matched, it looks like it's close to, but not exactly to, cobalt or silicon. I can kind of rule out these ones. So what I need to do is perform a specific heat calculation to figure out which one it really is. Specific heat, here's a look at with the lab at what it was. We put the sample into hot water, made it 100 degrees. We poured it into a cup of known massed, known temp water. It heated the water up, and we, based on that information, we were able to calculate the specific heat. Specific heat's based on this idea, Q equals M times C times delta T. We have two things that we have to solve though. First, we have to figure out how much heat H2O gained. And then we can come down maybe on number 2 and figure out specific heat of the metal. So it's a two-parter, this one. Heat of metal. Okay, how much heat did the water gain? I need to know its mass, its specific heat, and its change in temperature. So I find out how much water I had. I had 82 grams of water. It's liquid water, so its specific heat is 4.18 joules per gram degree Celsius. And the water changed from 13.6 to 20.8. 20.8 minus 13.6 equals 7.2 degrees Celsius. 82 times 4.18 times 7.2 equals 2468. I'm rounding. 2468 joules. That's how much the water gained. This gained 2468 joules. Well, where did that come from? Well, it came from the metal. So apparently if this gained 2468, the metal lost 2468. Given that information, I can do some fancy math to figure out what the specific heat of the metal is. So the specific heat of the metal, now if I rearrange this Q equals MC delta T and divide by M and delta T, that'll cross off. What I do to one side, I do to the other. Or, for those of you who remember round little buddies, Q equals M times C times delta T. If I cover up specific heat, because that's what I'm after, I put Q on top, mass and change in temp on the bottom. That's what I wrote there. Q, heat. How much heat did the metal lose? 2468 joules. What's the mass of the metal? I have to go way back up there to find out the mass of the metal, 78 grams. Not of the water, because now we're talking about the metal. And what's the change in temp of the metal? Well, when I started, it was in 100 degrees Celsius water. But when I put it into there, it ended up cooling down, and it's going to end up being the same temperature as the metal at the end. So how warm was the metal at the end? At the end, it was at 20.8. 100 minus 20.8 equals, calculator, 100 minus 20.8 equals 79.2 degrees Celsius. So I have a 79.2 degrees Celsius. If I do this calculation, 2468 divided by 78 and also divided by 79.2, that equals about 0.399 or zero point 0.4 joules per gram degrees Celsius. Between cobalt and silicon, which one is close to 0.4? This one. I'm going to declare that metal cobalt. The next one is all about substances. Substances can either be all matter, can either be a mix, or it's pure. And if it's pure, it's either an element or a compound. Elements have their own spot on the periodic table. They have one box and it's just them, and they'll have one capital and only one capital letter. They may have a small letter, but they don't necessarily have to. I am looking for elements, compounds, or molecules. Molecules are two or more atoms tied together. Let's just do the element or compound game first. One capital letter, that is an element. One capital letter, that's also an element. This one has manganese and oxygen. It's two different things tied together. That must be a compound. This one has hydrogen and oxygen. It's a compound. This one has potassium and chlorine. That's compound. This one has magnesium and bromine. Also a compound. Only one capital letter. Cr is chromium. It's got its own space. That is an element. And big C, little o, not big C, big O. Big C, big O would be a compound, but that's not what it says. You'll find cobalt on there. It has its own little box. That is an element. The next thing is whether or not it's a molecule. Is it two or more atoms tied together? Then we have to put an M there. This one is not. This one has three, so it's also a molecule. This one has one, two things. It's a molecule. In fact, every time we have compound, there's at least two things. Molecule, molecule, molecule. This one is not a molecule, and this one is not a molecule.